All right, so if you have a function y equals log base b of x, for b is greater than 1, the graphs look similar. So why is that? Well, if you take this logarithmic equation and transform it into an exponential equation, if this number b right here, if that's greater than 1, you are just raising that to an exponent, and the x and the y, they both increase together. The greater that y is, the greater that x is going to be. And they both, regardless of the number b, as long as it's greater than 1, it's going to act the same for values of b greater than 1. All right, see if you can figure out the transformation here. It says the graph of f of x equals log base 2 of x minus 2 is the graph of y equals log base 2 of x. What happens? What happens if this is the original and this right here is the transformation? Please see if you can figure that out. All right, if this is the original and here we did x minus 2, if we do minus 2 on the x value, remember when you add or subtract from x, it moves it left or right, but it's reversed. So x minus 2, okay, what that does, that makes it move to the right by 2 units. All right, so if you started with this and did x minus 2, it goes to the right 2 units. All right, next one up. The graph of f of x equals negative 5 plus log base 3 of x is the graph of y equals log base 3 of x. And see if you can figure out the transformation. All right, so this is the original and this is the transformation. So what exactly happens? Well, we have log base 3 right here of x, and we have log base 3 of x minus 5 right here. What does the minus 5 do? That makes it shift down by 5 units. All right, so we've covered that before, and the transformations apply to the log functions just the same. All right, last one. F of x equals 1/3 log x is the graph of y equals log of x. See if you can figure out the transformation there. All right, this one here is the original. And this one here is the transformation. So if you took the original log of x and you multiplied it by 1/3, what does that do? Well, if you multiply the entire, if this is y equals log of x and you multiply all of the y's by 1/3, that is a vertical compression. All right, and that's because the y values, if it's y equals log of x, the y values is how far up down the graph is. So if you multiply a y value by a 1/3, let's say you have a 9, you multiply that by a 1/3, that 9 becomes down here, that 9 becomes a 3. Okay, so a vertical compression, and that just means that the graph gets flatter. All right, so the domain of y equals log base b of x, x has to be greater than 0. So the term that you are taking the log of, all right, that right there has to be greater than 0. All right, example 1. Find the domain and give your answers in interval notation. All right, this is basically y equals log base 5 of 2 minus x. The term that you're taking the log of has to be greater than 0. All right, so 2 minus x is greater than 0. Isolating the x, I am going to do minus 2 on both sides. 2 minus 2 is 0, so that cancels. Bring down your negative x. Bring down your inequality, and 0 minus 2 is negative 2. Solving for x, we have negative x. To get rid of the negative, I am going to multiply both sides by negative 1. All right, so on both sides, I'm going to do times negative 1. On the left, negative 1 times negative x is x. And when you multiply both sides by a negative, you reverse the inequality symbol. Here it's pointing to the right, but I did times negative 1 on both sides. Now it is pointing to the left. Okay, negative 2 times negative 1 is positive 2. So x is less than 2. All right, in interval notation, if x is less than 2, let's say you have a 2 here, and it does not have the equal sign, so it does not include the 2, and it's everything less than 2. So I'll shade it in a different color here. So everything to the left of 2, okay, to the left, it runs to negative infinity. So in interval notation, you start with negative infinity, and you use the curved parenthesis, not the bracket, because it does not include negative infinity, and it doesn't include 2 either. So when you write the 2, you use the curved parenthesis. And this right here is your final answer. Okay, remember when you multiply or divide an inequality by a negative on both sides, you reverse the inequality symbol. All right, example 2. Here we have f of x equals log of x squared minus x minus 2. All right, the thing you're taking the log of, the argument, that has to be greater than 0. All right, so I'm going to start with x squared minus x minus 2 is greater than 0. All right, so we have to see where this equals 0 and plug in the numbers in between. And how do we set this equal to 0? Well, you need to factor it. Okay, so we have a coefficient of a 1. And this is a coefficient of negative 1. We just need 2 numbers that multiply to negative 2 and add to negative 1. All right, if you write out the factors of negative 2 times positive 1, if you added these 2, that's going to add to negative 1. All right, so we're going to use this right here and make 2 binomials. All right, we have x squared, so we're going to start with x times x, and then we're going to use negative 2 and positive 1. All right, and what we're going to do here, just for now, we're going to set this equal to 0. Anything times 0 is 0, so this can be 0, or this can be 0. All right, so we have x minus 2 equals 0. And we also have x plus 1 equals 0. All right, plus 2 on both sides, x equals 2. Minus 1 on both sides, x equals negative 1. So now we need to use a number line. Okay, I'll do it in a different color here. And on the number line, we have a 2 and a negative 1. All right, so this is 2, and this is negative 1. The smaller numbers are always to the left. And what we want to do here is plug in numbers that are in between the zeros. Okay, so let's see here. You want to pick an easy number. So to the left of negative 1, let's try x equals negative 2. All right. Now let's see if we plug in x equals -2. -2 minus 2 is negative. -2 plus 1 is negative. Negative times negative is positive. Between -1 and 2, let's try x equals 0. At x equals 0, 0 minus 2 is negative. 0 plus 1 is positive. Negative times positive is negative. Finally, to the right of 2, let's do x equals 3. All right, so last one here, x equals 3. 3 minus 2 is positive. 3 plus 1 is positive. So we have positive times positive, and that equals positive. All right, so at x equals 3, it's positive. We are looking for the ones that are greater than 0. Okay, the -1 and the -2 were the 0, so it does not include -1, and it does not include -2. But if we shade the positive areas here, we have x is greater than 2. And if we shade the positive areas here, we have x is less than -1. So how do we write that in interval notation? Well, let's see. X is less than -1 when it goes in the negative direction. It heads toward negative infinity. And for the infinity symbol, you always use the curved parenthesis because it doesn't include negative infinity. And it goes all the way to -1. All right, it does not include it, so you use the rounded parenthesis. And that is in union with, and you keep going to the right. Here's a +2. It doesn't include the 2, so you use the curved parenthesis. And the 2 goes, after the 2, it goes all the way to the right to positive infinity. All right, again, for the infinities, you use the curved parentheses. So this right here is the domain. All right, last one, example 3. See if you can figure this one out. So ln, this right here is the argument. All right, remember ln is just the same as log base e. So we're still doing logs, it's just log base e. All right, anyhow, the argument is x squared plus 1. And this has to be greater than 0. All right, if you square the x, that's always positive. All right, and plus 1 is always positive, so a positive plus positive is greater than 0. This is always true. All right, so this is going to be all real numbers. And how do we write all real numbers in interval notation? Well, all real numbers is the entire number line. It goes all the way from infinity to negative infinity. All right, that's the whole thing. So you start at, if you start at the left, you start at negative infinity, and it runs all the way to positive infinity. You use the curved parentheses because you never include infinity as an actual number. So that's it right there. All right, so in these examples, You must check the solutions in the original equation. All right, you'll see what I mean by that in a minute. Anyhow, in this equation, we're going to solve for x. Let's call this example 1. All right, here we want to solve for x. What I'm going to do is convert this to an exponential equation. All right. I sometimes forget how to convert, so I like to use the cancellation property. If you remember how to convert logs to exponential, that's fine, but I like to use the cancellation property. Here we have base 2. So I am going to make this whole thing the exponent. I'll do it in a different color here. I want this whole thing the exponent on the number 2. Okay, so this is now the exponent on the number 2. Whatever I do to one side, I want to do to the other side of the equal sign. So that's going to be 2 to the 3rd on the right. Okay, this base matches this base, so the 2 and the log base 2 cancel. We're left with the argument of x squared plus 3x minus 10. Equals, and 2 to the 3rd power equals 8. All right, now we're in business. This is a quadratic. In order to solve a quadratic, you have to set it equal to 0. The opposite of positive 8 is negative 8. I'm going to do that to both sides of the equal sign. Bring down your x squared. Bring down your positive 3x. Negative 10 minus 8 is negative 18. Bring down the equals. And of course, 8 minus 8 is 0. All right, how do we solve? We need to factor. This is a coefficient of 1, so just two numbers that multiply to negative 18 and add to positive 3. All right, let's write out some factors of negative 18. We have 6 times negative 3. If you take these two and add them, they add to positive 3. So that works just fine. All right, so we're going to write two binomials equal to 0. Since we're starting with x squared, we're going to start the binomials with x times x. This is positive 6 and negative 3. All right, like we said a few minutes ago, either of these can equal 0. So x plus 6 equals 0, and x minus 3 equals 0. All right, minus 6 on both sides will give us x equals negative 6. Plus 3 on both sides will give us x equals positive 3. All right, for each of these solutions, we have to test on the original. All right, so we're going to have to plug them in. We got to test them out. All right, the first one is negative 6. Let's go back to the original function, and we're going to plug in negative 6 wherever we see an x. So let's see what happens here. We have log base 2. And this is negative 6 squared. So the parentheses start the argument here, but you also need parentheses on the negative 6 since you're squaring it. Okay, so I'm going to put the parentheses again. Negative 6 squared plus 3 times negative 6. And then minus 10, close parentheses, equals 3. All right, so that's going to equal log base 2. And we have negative 6 squared, 3 times negative 6, minus 10, equals 3. All right, so that's log base 2. 36 minus 18 is negative 18. Minus 10 is negative 28. And that equals 3. Nope, that's a mistake. 36 minus 18 is positive 18. Minus 10 is 8. And that equals 3. Is that true? Let's see. This is log base 2. And can we convert 8 to a base 2? Well, let's see. 8 is the same as 2 to the third. So in place of 8, I'm going to sub in 2 to the third. All right, and when the base of the log matches the base of the number that's being raised to the exponent, those cancel, and you're just left with 3. Does 3 equal 3? Yes. Okay, so what number did we use? X equals negative 6. That answer or solution checks out. Now we have to do the other one. X equals positive 3. All right, so let me erase this mess here. All right, if you're taking notes, copy this down, and I'm going to erase this and plug in x equals 3 into the original. All right, we're going to do x equals positive 3. Wherever we see an x. And let's see what happens. Log base 2, parentheses, x squared is going to be 3 squared, plus 3 times 3 minus 10. Close parentheses, and that equals 3. All right, log base 2. 9 plus 9 is 18, minus 10 is 8, and that equals 3. Okay, and that's the same equation we had before. So we know it's true. We said 8 was the same as 2 to the third, and the bases match here, so this is basically just 3 equals 3. All right, that checks out, and that means x equals 3 is also a solution. All right, so we said to test it on the original, and both of them work. All right, last one in this section, example 2. We have log base 5 of this equals log base 5 of that. All right, since the 5 and the 5 both match log base 5, we can just set the argument equal to the argument. Okay, if you don't believe me, you can do 5 and make this an exponent on the number 5, and you can do 5 on both sides of the equal sign. Make this the exponent on the number 5. The 5 and the log 5 both cancel on both sides. So x squared plus 5x minus 4 is going to equal x plus 1. All right, we have a quadratic, so we need to set it equal to 0. This is positive x. I am going to do negative x. This is positive 1. I'm going to do negative 1. X minus x is gone. 1 minus 1 is gone. Bring down x squared. 5x minus 1x is 4x. Negative 4 minus 1 is negative 5. And that equals 0. All right, the coefficient here is a 1. We just need two numbers that multiply to negative 5 and add to positive 4. All right, if you did negative 5 times 1, they add to negative 4. If you did 5 times negative 1, that adds to positive 4, so that one works. All right, we're just factoring here. So we're going to use 5 and negative 1. All right, our binomial is going to start with x times x, so we can get x squared. And we're going to use positive 5 and negative 1. All right, either of these can be set equal to 0. So I'm going to do x plus 5 equals 0. And I'm going to do x minus 1 equals 0. Minus 5 on both sides, x equals negative 5. Plus 1 on both sides, x equals 1. And what do we have to do with these? We have to test them out. All right, test on the original. I used the word test last time. I'll say plug into the original. All right, so let's see if it works. Start with negative 5 on the original. All right, so we have to do all the x's here. Negative 5, negative 5, and negative 5 on all the x's. All right, let's see if we can make it work. Start with log base 5. Parentheses. Negative 5 gets squared. All right, whenever you square a negative, use the parentheses. Plus 5 times negative 5. 5 times negative 5. Minus 4 equals. Minus 4, close parentheses, equals. Log base 5 of negative 5 plus 1. All right, I can see already it's not going to work. I don't even have to do this side. Look what happens on the right. We have log base 5, and negative 5 plus 1 is negative 4. Can you take the log of a negative? No. So for x equals negative 4, that's a no. All right, it failed the test. All right, it failed the test on the right-hand side. Just curious, right here, this would be 25 minus 25. That'd be 0 minus 4. Yes, this would give you negative 4 as well. But it doesn't matter if it's log of negative 4 on both sides. You can't take the log of a negative. So that's a no. All right, for the, I'm sorry. This was not negative 4 that I plugged in. It was negative 5. I got the log of negative 4, but this is supposed to be negative 5, and that is the solution or answer that failed. Okay, so for x equals negative 5, gone. Now let's try x equals 1. Plug it into the original. All right, if you're taking notes, I am going to erase this. I'm going to erase this in blue right here. All right, let's try x equals 1. All right, go back to the original equation. Wherever you see an x, you want to plug in a 1. Okay, that should be pretty easy. All right, so we start with log base 5, parentheses, 1 squared plus 5 times 1 minus 4. 1 squared plus 5 times 1 minus 4. And that equals log base 5 of 1 plus 1. Okay, log base 5, recopying. 1 squared is 1, plus 5 times 1 is 6, minus 4 is a 2. On the right, log base 5 of 1 plus 1 is a 2. We got the same thing on both sides. What did we plug in for x? We plugged in x equals 1. All right, so that checks out. All right, so x equals 1 is the only answer. The -5 did not work.